All right, now we're going to talk about the natural log function. You remember when we did the general power rule and we would integrate any x to a power, then we could, very straightforwardly, this is x to the n plus 1 divided by n plus 1 plus c. For all cases except where n equals -1. And you can see that that would really mess you up in your denominator here. We are going to discover what happens when we do try to integrate x to the -1 dx. Now it turns out that the natural logarithmic function, ln of x, is defined to be the integral from 1 to x of 1 over t dt. And of course, x has to be positive. The domain of the natural log function is a set of all positive real numbers. Now let's look at this right here. Okay, we're integrating from 1 to x. So if x is greater than 1, then we're taking the integral from left to right, and we're going to find this area right here, which is positive. However, if x is less than 1, then we're going to be going back. We're going to be going from right to left. And so this integral is going to be negative. So you can get all the negative numbers by integrating from 1 to x when x is less than 1, and all of the positive numbers when integrating from 1 to x when x is greater than 1. Now let's look at slope fields. Don't panic too much about slope fields. I just want you to kind of see them and experience them. If I have a differential equation, dy dx is equal to 1 over x, basically what I'm saying is let's just look at this and let's just see what is the slope, because that's what this is. This is slope at any point. And I'm saying that the slope at any point is equal to 1 over x. Now, it doesn't depend upon y, so if I go up or down, then the slopes are all going to be the same. When we've got y's over there, it's going to change a little bit, but we're going to do a whole unit on that. It turns out the slope field for dy dx equals 1 over x is a solution set for y equal natural log of x. So if I were to, let's look at y equals natural log of x. X at 1, log of 1 is 0, and it starts at 1 and then it curves up. Remember, it's concave down, and then it goes on down to infinity. These are particular solutions. You see, if I try to graph log y equals natural log of x over 4, then I know log of 1 is 0, so this is 0 when x is 4. All right, then I'm just sketching the slope at any given point along this curve. That's what the slope fields give you. Now you see how it changes if instead of log x over 4, I use log of 4x, then my 0 is back here at a quarter. It shifts where it is, but it doesn't change the fundamental shape, and that's what you can see as you look at these slope fields. You're going to get really good at looking at these later. All right, your turn. Turn off the video. Do a sketch of y's log of 2x. When you're done, turn the video back on. We're not done yet. Okay, let's talk about some properties of natural log functions. I kind of alluded to them a little bit. And you need to know all of these properties. They're excellent multiple choice sorts of questions. The domain is 0 to infinity, and the range is -infinity to infinity. You can also say all reals. The function is continuous, increasing, and 1 to 1, and the graph is concave down, always. Now, logarithmic properties. Again, you need to know these, and you need to be able to use these. Natural log of 1 is 0. Boom. Log of a times b is log of a plus log of b. The log of a to the n is n times log of a. So whatever your power is, you drag it to the front and you multiply by it. And the natural log of a divided by b is log of a minus log of b. Now you can look at this one and say that this is log of ab to the negative 1, and then you can use your power rule or your product rule here. So this is log of a plus natural log of b to the negative 1, and then you can use your power rule to say this is natural log of a plus, and my power is negative 1, natural log of b. So it's natural log of a minus natural log of b. Okay? We can expand this one right here. This is kind of a fun one to prove. I actually enjoyed doing this. Suppose I have the natural log of a to the n. That's the same thing as the natural log of a times a times a dot 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 a, where I have n of these. So that's the natural log of a plus the natural log of a plus the natural log of a plus dot dot dot. You got the idea, natural log of a. Now how many of these you're going to have? Of course you're going to have n of them. So this is n natural log of a. Isn't that cool? All right. Yeah, I'm easily amused, I know. Okay, let's work with some logarithmic expressions. Let's see, the natural log of 10 over 9 is the natural log of 10 minus the natural log of 9. That's all I want you to do on these. Now let's look at this one right here. This is the natural log of 3x plus 2 to the 1/2. So I'm going to use the power rule. This is 1/2 times the natural log of 3x plus 2. Can I do any more? No, not really. Because I can't just break these up. They have to be multiplied by each other. You can't just break those additions up. Don't do it. What if we try this one? Natural log of 6x divided by 5. Well, this is a natural log of 6x minus a natural log of 5. Am I done? Not quite. We can break this up as a natural log of 6 plus a natural log of x minus a natural log of 5. Now that's about as down as I can get it. This one, oh, this one's flat. All right, just take a deep breath. Let's do one thing at a time. Let's use the fraction. This is natural log of x squared plus 3 squared minus the natural log of x cubed root of x squared plus 1. Now we can use the power rule. This is twice the natural log of x squared plus 3 minus the natural log of x minus the natural log of x squared plus 1 to the 1/3. I'm going to go and change that power. They're both minus because I've got the negative there. Now, is there any more I can do to this one? I'm not seeing any more. Natural log x squared plus 3. I can't factor it at all. Okay, minus the natural log of x. Can't do any more with that. Minus 1/2 the natural log of x squared plus 1. Okay, now you're done. You can't break that down anymore. If that was a negative sign, then you could factor it. But I didn't give you that. Okay, your turn. When you're done, stop the video. You're home. You like my ears? These are fun. They really are. I hope you enjoy doing them as much as I do.